Hi there, it's Professor Monte again. Let's look at simplifying radical expressions, but by factoring. Okay, let's just look at some examples. So I've got the square root of 12, and 12 is not a perfect square of any nice number, any whole number. Uh, for instance, 3 squared is 9, 4 squared is 16. It's somewhere in between there, so it's not a perfect square. Well, by factoring, if you're good at seeing what squares are, you may say, hey, you know what? I know that 12 is 4 times 3. And I can do the square root of 4 times the square root of 3. And I know the square root of 4 is 2. The square root of 3 doesn't simplify. I just leave it that way. And that's my answer. I can say, oh, that's just 2 times the square root of 3 is my answer. Now, that's all good and well. And if you see it that way, do it that way. That's the quicker way to do it. I'm going to show you a different way to do it. I don't always see all the perfect squares or perfect cubes, etc., and not all my students do either. So I've come up with a way that I think simplifies things even more. So let me erase this and start over. So here's what I do. I've got a square root. That means I have to have something squared or two of them to come out. Well, if I look at 12, and I'm going to break down 12 into prime numbers. I can divide 12 by 2, it goes in there 6 times. I can divide 6 by 2, it goes in there 3 times. So what I have is I have 2 2's and a 3 that all multiply together to get 12. 2 times 2 is 4, times 3, 12. Well, in order to come outside, I need 2 of something. Oh, I have 2 2's. That comes outside as one group. The 3, there's only one of them that stays in. I like to call it the buddy system. Hey, we want to go outside and play. We're inside the house. We want to go outside. We say, well, we only want you to go outside if you have a buddy. And the 2 say, oh, I have a buddy. Can we go outside? And we say, yeah, but you have to stay together. Oh, here's my group of 2's. They're together as 2's outside. 3 says, hey, I want to go outside and play too. And we say, I'm sorry, you don't have a buddy. Until you find a buddy, you have to stay inside the house. And that's my answer. And what I like about this, it doesn't just work for square roots, it works for cubed roots also. So now I've got the cubed root of 72. I don't know a nice number of cubes that equals 72. But let's do the same thing. Let's break it down, see if I have groups of 3 to go outside. So let's see. And remember, I'm dividing by prime numbers. 2 is my smallest prime. Let's see. 2 goes in there 36 times. Now, 36 is a perfect square, but I don't care because I need a cube. I'm just going to continue to go down by primes. 2 goes in there 18 times. 2 goes in there 9 times. 2 doesn't go in there anymore, but 3 goes in there 3 times. And I say, oh, this is easy. I need 3 of them in a group to go outside. The 2's can go outside again. But they don't go out as 2 to the third because the third root of 2 to the third is just 2. They go outside as a group of 2's. And 3 say, we want to go outside. And we said, I know there's 2 of you, but there has to be 3 to go outside. So they both have to stay in. It's still the third root. I still have 3 times 3. You might write it 3 squared. However you want to write it. I'm going to write it 3 times 3 for now because that's not going to be my answer. My answer is, 3 times 3 is 9. So it's 2 times the cube root of 9. I'll just box my answer right here. And so that's how we simplify it. And then one last one, I've got some variables here. Well, remember the square root is the 1/2 power. When I've got exponents, here's what I like to do. Because this really means this. It means a to the 6th, b to the 9th, but to the 1/2 power. And remember, I multiply those. So the way I look at it, 6 times a half is just dividing 6 by 2. So when I have exponents, here's what I do. I say, okay, let's look at my a's. I have 6 of them, and I'm going to divide it by 2. Oh, that's just 3. So 3 of them come out. That's 3 groups of 2 is what that means. So on the outside, I'm going to get a to the third. What about the b's? Let's see what happens there. My b's, well, this time I have 9 divided by 2. 2 goes into 9 4 times, but that would only be an 8, and I have a remainder of 1. And what that means, 4 groups can come out, but 1 has to stay in. So anytime I have a remainder, that's how many stay in. So I'm going to say, oh, my b4 come out, b to the fourth, because I had 4 groups of b that came out, but I had 1 b that stayed in. And that's my answer. I really like this method of using division to simplify my exponents real quickly. Let's do one more example real quick just to show you how it works. So say I've got a third root of x to the fourth, y to the ninth. Well, for my x's, I'm going to say, oh, 4 divided by 3, right? 4 divided by 3, that's 1. 3 goes into 4 once with a remainder of 1. So 1 comes out, 1 stays in. With my y, I have 9 divided by 3, which is just 3. Well, all 3 come out. Nothing left to stay in. So I've got 1x came out, 3 y's came out, but 1x had to stay in. So it's still the third root of x, and there's my answer. So practice these. I like this method real well. I like the factor. Now, you may be real good at knowing the cubes, and you may have looked at 72 and said, oh, that's 8 times 9. The cubed root of 8 is 2. The cubed root of 9 I don't know, so I leave it in. I'm not that good at seeing these right away, so that's why I break it down in primes. If it's a cubed root, 3 have to be in a group to come out. Anything less than that stays in, and then just all gets multiplied together. And I love it with the exponents where you just divide by whatever this root is. Oh, it's a square root divided by 2. However many times it goes in, if it goes in evenly, those come out. Whatever's a remainder remains inside. Okay, so work with those, practice. I think this will be a big beneficial way for you to look at it, and I think it really simplifies things.